Welcome to the second day of Darwin Festival 2023. Our speaker this morning is Steve Young. He's a professor of geography and sustainability at Salem State. Steve got his bachelor's at Yale University, a master's from University of Vermont, his PhD in geography from Clark University. He does field work in both New England and China. Among his many interests is the use of satellite imaging to analyze climate change and deforestation. In addition to his academic research, Dr. Young does outreach to the general public, including a long-running art photography exhibition entitled Macro or Micro, which has been on display at the Museum of Science and in Tehran, Iran. Today's talk is titled Impacts of Climate Change. They have only just begun. Please welcome my old friend, Dr. Steve Young.
Okay, I need to turn on my various microphones so people can hear me. And thank you, Paul Kelly, for that introduction. Paul and I, years ago, we team taught biogeography. And that macro micro exhibit is one that I do with Paul. Paul does microscopic imaging, things that are like the width of your hair. And I do satellite imaging of things that are like 100 kilometers in size. And we put them up on the wall, and it's hard to tell which is which because the Earth cracks and the Earth does things at different scale. And you have nothing for scale. And anyways, it's a very interesting thing. So I have a strong affinity to the biology department. I have a master's degree in forest ecology. And in geography, I've learned how to look at the world from a spatial perspective. And so I've been able to marry my biological background with my geographic studies. I want to thank the biology department, the geography and sustainability department, the Earth Days Planning Committee, and the Charles Albert Reed Trust for sponsoring this talk today. Very appreciative. There's a lot of people who do a lot of work in the background to make this happen. All right, that was a preview of the talk because we ran through it to make sure it worked, and I left it at the end. I do want to make a shout out to people that are online. Thank you for joining us today, and for all of you here today. So I'm going to talk about climate change. The impacts have only just begun. And so in this talk today, I'm going to talk about the science of why our climate's changing, what to expect in our world as it warms, changes happening in New England, and then how Salem State University is engaged with solutions to our issue. So science, right? Most of you are in biology. What is science? It's about answering questions. It's a methodology in which we understand our world. And it's based on observations. We go out, we gather data, and then we look at those observations and we try to come up with some sort of answer to what's happening. And then we do lots of experiments to see if that in fact is right. And we kind of refine. Science is always refining itself. It's transparent. There's nothing hidden. There's no secret recipe. It's very open to everybody, our data, our methods. So one question is our climate changing? And so we've got all kinds of instruments out there collecting data. We collect lots of data in our atmosphere about temperature, wind, moisture. And then this is humans are pretty ingenious. This is a really cool temperature measuring device and making observations in the ocean. And what it does is it drops down to about 1,000 meters below the surface and hangs out for many days collecting data. Then it drops down further, and then it creates a profile coming back up, pops up, sends its data to a satellite. That satellite sends that data to a receiving station. And then we're able to get a good glimpse of what the temperature is like inside the ocean. And we've got hundreds and hundreds of these around the world, bringing in that kind of observations. So one of the conclusions of those observations that we've been doing for quite a long time is very clearly recently the world has started to warm up. And I'm going to focus on this graph a little bit. This graph, it's titled as Global Average Temperature Change from 1850 to 2021. And each one of those red dots represents how far that year varied from a long-term average. It's called an anomaly, right? An anomaly is something that is different than the norm. And in this case, we took 1850 to 1900, we added up the annual temperature, global annual temperature for all those years and divided by 51 and got a long-term average. Then we compared each year to that long-term average. And those red dots are how each year varied from that long-term average. And what we see very clearly is between 1960 and 1980, the long-term trend bent upwards. It's been relatively flat, and each year it goes up and down, up and down, up and down, because the Earth is a complex system. It's not a linear change, but you can see that long-term change. And also in science, we don't rely on just one data set. We often look at multiple data sets. And so these multiple data sets of different ways of measuring the data, collecting the data, all show that change has happened. And if we go back in time, there's ways that we can figure out the temperature in the past. And one reason we look at that past data is what's happening today, normal, not so normal. And what we can see from these data sets, the most recent temperature, which we've measured with actual thermometers in the ocean and the atmosphere, is that red line at the end. And it is a distinctive change, which we are experiencing now. So the reason why the world is the temperature that it is, it's actually a pretty simple equation. It's how much solar radiation we get from the sun compared to how much terrestrial radiation we send back to space. Everybody, even ice cubes, radiate energy. As long as you've got some energy, you radiate it. The sun radiates a tremendous amount of energy to Earth. Earth then sends it back to space. And when the amount of energy leaving Earth equals the amount of energy coming in, temperature stays the same. If more leaves than comes in, then it gets colder. More comes in than leaves, it gets warmer. And that's what's happening today. We're continuing to get the same amount of incoming solar radiation, but we're slowing down the energy of the Earth leaving. We get energy from the sun, and so I want you to see the yellow line is an actual measurement. We have great measurements of how much energy the sun is putting out. And the red line, which goes to the vertical column on the right, is temperature. And we can see there often is a correlation between sun energy, incoming sun energy, and temperature, which we see in the early 1900s. But since about 1960, 1970, solar radiation has slightly declined and temperatures increased. So the issue is we're not getting any more energy from the sun. It's not, we're not warming up because of that. What's happening is we've changed the chemistry of our atmosphere. We've put these gases up in our atmosphere that let the sunlight in, but they stop the Earth's energy from leaving. And the more of those molecules we put in the atmosphere, the slower energy leaves the Earth system because it's absorbing that energy and sending some of it back to Earth. And the more of those gases we have, the less energy leaves the system. So what's happening on Earth is like this example of a bathtub. As long as the amount of water coming into the bathtub is equal to the amount of water leaving the bathtub, that little ducky is going to stay at the same level. But what we've done is we've squeezed that drain pipe. By putting those gases in our atmosphere, we're slowing the amount of energy that can leave the system. And so just like that bathtub, the Earth is slowly filling up with heat. Our oceans are getting warmer. Our groundwater is getting warmer. Our soil is getting warmer. And on the gross scale, we can do that. We can measure. We have satellites that can measure how much energy is leaving the Earth and how much energy is coming in from the sun. And we've actually, one thing we do in science is we quantify it. We've quantified actually how much extra energy is being saved on Earth. Where is that energy being stored? Most of it's in the ocean. And that's one reason why we really don't feel it. We don't live in the ocean. Over 90% of that energy, the oceans act like a battery, storing that excess energy that our system's creating. Understanding the past. Right, I showed a little bit earlier, having a little bit of understanding of how things changed in the past gives us a perspective of how things are changing in today's world. So one of the cool things that scientists do is they get these things called climate proxies, right? We didn't have thermometers back 800,000 years ago to measure the air temperature. So we use things in nature that help us find out about temperature and other things. And ice cores like in Antarctica and Greenland, we can look at the molecules and tell what the temperature was like. And also parts of gases from the atmosphere were captured in that ice. And some of these, this one goes back 400,000 years. Some of them go back 800,000 years. And what I want you to notice is this is a classic way that we look at data to see if there's any relationships. We're looking at carbon dioxide concentrations in the atmosphere and temperature. And on the right-hand side is the temperature, which is the purple line. And on the left-hand column, we're looking at concentration of carbon dioxide. You should be able to see that there's a very, very close relationship between those two, carbon dioxide and temperature. In fact, the amount of carbon dioxide in our atmosphere has often been referred to as the thermostat of Earth's temperature. Here's another diagram showing that relationship. This one goes back 800,000 years. And I want you to see the star up at the top right-hand corner. That's the concentration of carbon dioxide in our atmosphere now. It's nowhere near where it's been for the past 800,000 years. And so that is one of the reasons why our climate's changing so significantly, why it has that upward bent. Right? This is measurement. There was a person thought, hey, it'd be cool to measure gases in the atmosphere, and I'm going to get a grant to go out to Hawaii and put this thing up on an island, volcano, because there's not a lot of humans or industry around. And started collecting carbon dioxide as one of those chemicals, and we've got a great measurement of in fact we are increasing those greenhouse gases. Right? Science is all about observations. Here is an interesting graph. This is the total amount of carbon dioxide that we're putting in the atmosphere. See that little dip at the top right there? That was COVID, right? Everything shut down. We stopped driving around and stuff, but it only made a small dent. Our way of life is very carbon related, and we need to shift that. Methane, I just measured this just got this graph the other day. Methane is another greenhouse gas. We were told natural gas was going to be the link to the future, and it turns out that we're releasing a lot to the atmosphere also. So one thing about science is we can model into the future. And there's a group of scientists, the IPCC, that look at all the data that's going out there, and they try to figure out what's our future going to be like. And they have said, based on science, that we should really try to keep the Earth's temperature from not rising more than 1.5 degrees, because we've looked in the past, anything of that magnitude is going to bring about a fair bit of change, like melting the glaciers and things like that. So we want the carbon dioxide is driving the temperature change, so we need to stop putting that in the atmosphere. So a lot of towns and our university has made a goal of 2050 become carbon neutral. So we've got momentum going in one direction. We really need to change as a society and change fairly quickly to get down to not putting so much carbon in the atmosphere. All right, that's the end of most of the graphs. There are a couple more to come, but so what can we expect in our warming world? We know, right? We know the relationship between these greenhouse gases and Earth's temperature. So here are some observations which have been happening. Up at the top, we see it's called the base years. It's 1951 to 1980. Often when we're studying climate, we'll take like a 30-year period as kind of our measuring rod, our standard. And then we took decades after that to look at how temperature was changing in the Northern Hemisphere. And you can see we kept the same base period. And what's been happening is we are shifting clearly into a warmer world. It's not a fluke thing that this winter's been pretty warm. And also there is wild weather. Just because we broke records of cold about a week ago, doesn't mean that we're not warming up. All right. This is, if you want to understand what's going to happen in the future, this is an important graph to understand. This is how much moisture the atmosphere can hold. And so when the atmosphere warms from 20 degrees to 40 degrees Fahrenheit, you can see it doesn't increase the water availability. The bottom of this graph is temperature, going from cold temperatures on the left to warm temperatures on the right. The scale on the left is how much water the atmosphere can potentially hold. What's the room? What's the capacity for moisture? Going from 0 up to 60. And you can see that 20-year change from 20-degree change from 20 to 40, not a lot of capacity changes. But from 80 to 100, it increases dramatically. This past year, we've had tremendous amount of floods and we've had tremendous amount of drought. And it's all driven because a warming world lets the atmosphere hold more moisture. So now the relationship, greenhouse gases are pushing the temperature up. The temperature is making the atmosphere be able to hold more moisture. A warmer atmosphere increases evaporation. There's more energy in the air. So it goes into evaporating water molecules. And it can hold more moisture, so it takes longer for that moisture to leave the air. So we get droughts. I'm sure many of you are aware the Southwest United States is drying up, and it's been drying up for a while. Lake Mead, Lake Powell, major reservoirs for water for the Southwest, and also electricity production is decreasing dramatically, right? They found bodies that have been put in oil barrels and stuff that were sitting on the bottom of the lake have become above water now. China last year had historic droughts, and they've got a long recorded history. Major lakes dried up, rivers dried up, and the reservoirs dried up so much that they had to cut back on electrical production, and they had rolling blackouts, as did other parts of the world. Europe, all of a sudden, these sunken ships that were downed in World War II were appearing out of the river because the river is almost dried up. Navigation had to stop. We had a drought, right? We live in a really humid part of the world, and we had a pretty punishing drought. What's happening is, and I'll talk a little bit more about this in a minute, but our winters are warming the fastest, and our summers, and most of the precipitation now, added precipitation comes in the wintertime. The summer precipitation stays kind of the same, but it's getting warmer, so there's more evaporation going on. And so we've had a number of droughts recently, a higher frequency than we usually have. Also, by warming, it means when it rains, it can now hold a lot more water than it ever could hold before. So when it rains, it dumps a lot of water on us. And so we've seen, last summer, we saw incredible floods. Death Valley, in one day, it had almost a year's worth of rain. Hurricane Ian. So a 1 in 1,000 year storm means that it's likely in 1,000 years you might get this kind of storm, right? It's not very likely. We're seeing more and more of these. Pakistan, unbelievable amount of monsoon rains coming in, and just the Indus River just flooded so many communities. China, there was a city where they had a new subway system, 10 years old, and so much water came in, people drowned in the subway cars. It was never designed, never imagined that there would be so much flooding to happen. New Zealand, Auckland the other day, got a summer's worth of rain in one day. Jia Chang Tu was a master's student here a few years ago. Now she's getting her PhD, and we're working on this paper about looking at Shanghai. And when this started about 2 years ago, she and others proposed doing a 1 in 1,000 year flood survey. And I thought, that's crazy. That's not going to happen in Shanghai. Now I feel like, wow, things have really changed, because we are seeing more and more of those floods. Okay, just want to make sure of my time. So the pandemic happens, and 2 of my sons come home from college, and they're working on their college class at home. And I say, hey, I have this great idea. Let's gather data. Let's look at weather and climate in New England. And one of my sons says, yeah, no, I'm going to play video games. Thank you. And my other son said, okay, I'll do it. And so we looked at temperature data for all the states in New England from 1900 to 2020. And we were so astonished by what we found, we decided to publish it, and it got accepted and published. And so here are the little pinpoints of the different weather stations where we collected data from 1900 to 2020. And these were one of our results. The orange line is decadal temperature in New England. So we average data, not yearly, but by decade, get a more general sense of what's happening. And so each dot represents the average change in temperature for that decade. And so the blue line is the change in global temperature, what's happening around the world. The orange line, what's happening in New England. And those bars that go up and down are what we call error bars. Scientists, we always say, well, this is our area of uncertainty. When those areas of uncertainty do not cross between those two lines, it means there's a significant difference between those two trends. And what this graph says, New England is warming significantly faster than the rest of the world. We happen to live in a place where, and right, there's no snow. It's February. Often, the bummer about the Darwin Festival is it's in February, and sometimes snow happens, and things get canceled. Not even close this year. And one big finding was winters are warming much faster. And that's what's happening in the world, or the colder places are warming faster than the warmer places. And so our 3.2 degrees Celsius is almost 6 degrees Fahrenheit. Our winters have warmed up quite a bit. Yeah, precipitation now comes a lot more as rain than as snow than it used to. We should actually have had a fair bit of snow this year, but it came as rain. And that's my son. And after we published it, actually the Boston Globe picked up on the article and published it. So if your parents ever suggest doing some data analysis or something, you should say yes. Another article that I did with a graduate student was we looked at snow cover and temperature in North America. When light hits snow, it reflects and doesn't pass much energy off. When there's no snow, the light doesn't reflect as much and the energy stays here. And that's one reason why New England's warming faster than other parts. Also, just off our coast, the Gulf of Maine is one of the fastest warming bodies on Earth. And one reason is the Gulf Stream is pushing a little bit further up, and it's pushing that warm water into the Gulf of Maine, which is also making New England warm. Yeah, last semester, a student asked me, why all of a sudden scientists interested in climate change? We've been interested in a long time. And right, the first paper was published back in 1896, projecting how the world is going to warm to carbon dioxide. Even the fossil fuel industry's scientists in the 70s published and predicted what was going to happen. And unfortunately, the fossil fuel companies use that information to raise their platforms because of sea level rise, to invest in Arctic oil because it's going to warm up in the Arctic. Chip on my shoulder. So biology, right? There's a lot of things that climate change in New England touches upon, but in biology, we're starting to experience kind of ecosystem disruption. Land ecosystems, marine ecosystems, especially, because remember, that's where a lot of the heat's being stored. Also, not just the warming temperature, but the drastic change in weather, the floods and droughts. It's hard to survive through such extremes. Species are on the move, are migrating. Long Island Sound used to have lots of lobsters. Now they have hardly a single lobster. They've all migrated up to colder waters. Same thing happening on the land. Health issues. If you're in biology in the health profession, you're going to see a lot of new things, stressors, because of the climate, because of the heat, because of new diseases that are coming into the area that we're not accustomed to seeing. And also being aware of certain people in our population that are more vulnerable to climate change, that don't have good health care insurance, that don't have access to air conditioners, and the like. Increased pests and diseases, disruption. So that's where we are. We know that our world is changing, becoming warmer, and there are these different weather events that are happening. And we know we've got to reduce our carbon footprint. And so one of the things I love about Salem State is we are very involved we've made a pledge for 2050 to reduce our carbon emissions. And so Salem State is fostering sustainability in our facilities, in our culture, and in our education. Facilities wise, we've got solar panels on a lot of the buildings on campus. Not only that, our library, we've got geothermal energy where we're taking energy from inside the earth to help heat and cool the library. Our university has won awards for decarbonization plans. And with Project Bold, where we're going to reimagine North Campus, we're also going to include a lot of decarbonization. In fact, Salem State is one of the leading institutions in moving forward towards decarbonization. Changing the culture, trying to change the culture on campus, EV charging stations on campus, a bike share program on campus, planting pollinator gardens, having recycling and reuse tables in the dorms, right? We used to not know what to do with those possessions we didn't want anymore that were still good. We often threw them away. Now we share them. So the culture on campus is changing in a sustainable way. Education. There's a lot of education that goes on campus about sustainability. In my department, we often teach about how to use geospatial technologies, such as GIS and remote sensing and drones, to gather data observations about what's happening. Activism also. I'm going to tell you a brief story. Must be now 8 years ago or so. Missouri was president, and the students were trying to push Salem State to divest our endowment from fossil fuels. And an hour before the Board of Trustees meeting, when they were going to decide it, President Missouri came and saw Noel Healy and myself and said, because we were pushing this, so the Board of Trustees are not gonna divest. It's too much of a thing to do. So many students showed up to that Board of Trustees meeting. The room was filled with students. They changed their mind and they divested from fossil fuels. And Professor Healy got us into a pool with a number of other universities, about 10 other universities, and there was $59,000 to share whatever university divested from fossil fuels, and Salem State was the only one. And so we got this fund, and then Professor Healy insisted that the fund go 100% towards scholarships. And so we've established 2 climate change scholarships for $1,000 each every year. From that money we won because the students demanded that the university divest from fossil fuels. And I'll tell you, that's one of the most powerful moments I've experienced at Salem State, seeing the collective voice of the students. And we do a lot of work out in the community. My department's got this exhibition about taking action with mapping, where we show sea level rise effects on the North Shore. We document sea level rise. My colleague, Marcos Luna, focuses on climate and equity. And there's a lot of climate justice work going on. In fact, my student who I'm going to call up here in a minute, Danny and I are going to go in a few weeks to Honduras. There's a coffee cooperative, and they want to reforest the areas that have been destroyed, and they want to get carbon offset money, but they've got no way to verify how their plants grow. So we're going to go down there and teach them how to fly a drone so that the farmers themselves can verify the trees that are growing and get carbon offset money, instead of that carbon offset money going to other groups. So our future world is arriving now. Our climate, climate's been stable for a long time. And we've created an incredible civilization based on that stability of climate. And now we live in a time of instability. And so we need to change. We need to change. It's not the end. We need to change how we interact. The type of economy that we had that worked really well in a stable economy is not going to work in an unstable economy. So we've got to change our ways. We've got to change our culture. We've got to change our economic system. For example, the fossil fuel industries like ExxonMobil made a record profit last year, and it's their product that is changing the climate. And that's how off our economic system is right now. But we know what to do in the future, and how to change our facilities, our culture, our education. So this type of conversation is going to continue this spring. Every spring we have a week where there is, we call it Earth Days Week, where we educate and celebrate about our environment. So there's 3 things I hope you got from today. One, a little bit more of an understanding of the science of climate change. A little bit of feeling of the urgency, right? There is urgency that we change things, right? The hotter the air gets, the more moisture we're going to see these droughts and these floods. Obviously, not everybody's going to be involved in climate change stuff in their life, but being aware of climate change, and there's little things in your life where you can make a difference, whether it's what you choose to eat, whether it's what who to vote for. Coming from an educated standpoint to try to change things, we can all do that. Some of us will continue into education and stuff. And finally, I hope you feel some pride about Salem State. We really are one of the leading institutions in New England on trying to change to a more sustainable way of life. And now I want to invite my student, Danny Schutzfeld and Fried to show a video that he put together. And I'm super proud of students at Salem State.
All right, so today we're going to show you a quick video that me and another classmate, Becca, made. It was back in 2021. It was right after we both took the geography department's drones class with Professor Young. And he approached us as the class was wrapping up. He had a little extra grant money from splash grant from the Center for Research and Creative Activities. And they were doing some research in the Great Marsh out in Essex. And we had the opportunity to fly the area, collect a lot of above ground imagery, and we put this little PSA together to kind of inform people what exactly is happening. Known for its stunning views and vast wildlife, the Great Marsh is one of the most important ecosystems in New England. This area covers over 25,000 acres of land in the North Shore, with half of it being salt marshes. The Great Marsh provides the perfect habitat for plenty of plants and animals, including 300 species of birds that call this area home. The marsh is an important resting and feeding ground for thousands of migratory birds that visit every year, and is utilized as a nursery ground for many different aquatic species. Coyotes, raccoons, deer, and other mammals can be spotted lurking through the marsh in search of food and shelter. While the Great Marsh is important to the environment, it is also very beneficial to humans in many different ways. Salt marshes help protect the shoreline from erosion and improve water quality by filtering excess nutrients from any runoff. It acts as a buffer against heavy wave action and storm surges between the ocean and the mainland. They also decrease flooding during storms by reducing the flow of floodwater and absorbing the rain. The Great Marsh also benefits local cities and towns in Massachusetts economically. Hundreds of tourists visit this area each year for outdoor recreational activities such as bird watching, nature photography, hiking, hunting, fishing, and boating. About 95% of the land in the Great Marsh is used for recreational activities and tourism. The shellfish industry is huge in Massachusetts, and the Great Marsh provides ideal conditions for clamming. Unfortunately, the habitat and benefits of the Great Marsh may be at risk as our planet undergoes climate change. As more carbon dioxide gets released into the atmosphere, the surface temperature of the Earth rises more and more. Since 1880, the average global temperature on Earth has increased slightly over 1 degree Celsius, or about 2 degrees Fahrenheit. Although it does not seem like much, this increase in surface temperature causes devastating impacts, especially on ecosystems such as the Great Marsh. Sea level is currently rising due to the expansion of seawater as it warms up. Today, we are already seeing the impact sea level rise has on the Great Marsh. The sea level rise affecting salt marshes model, done by the Massachusetts Office of Coastal Zone Management, found that the current rate of sea level rise will cause areas that are typically irregularly flooded to become regularly flooded. This clip was taken during a king's tide at a salt marsh in Essex, Massachusetts. This allows us to see what the tides will look like in the near future. As you can see, the tide goes up against the only access road to the Essex County Greenbelt's headquarters. Erosion and flooding has also been a major issue and will continue to get worse as time goes on. A possible increase in storm intensity from warming sea surface temperatures combined with the already existent sea level rise, could cause areas not typically flooded to be completely flooded for short periods of time. As climate change progresses, winters in New England have shortened and are becoming warmer. Shorter and warmer winters increase the probability of invasive species and pests entering the Great Marsh, only to cause devastation among the marsh's ecosystem. Other impacts of climate change include extreme drought, especially in the western part of the United States. Currently, people are battling large wildfires out west, and as the jet stream carries the smoke from those wildfires across the U.S., we get a gloomy haze in the northeast, as shown here at the Corbett Salt Marsh in Essex, Massachusetts. Although this haze is not directly impacting the salt marsh as much as sea level rise does, it is concerning to see that a climate change-induced wildfire burning hundreds of miles away can cause smoke to fill the air at one of our most precious ecosystems in New England. As wildfires become more frequent, it may be necessary for us to see the impact air quality has on our Great Marsh. The question raised here is, how will these impacts on the Great Marsh affect us? As sea level rise causes irregularly flooded areas to be covered with water, infrastructure such as roads, buildings, and sidewalks located near a marsh will be at risk. A large storm event or even an irregularly large tide could cause erosion near important infrastructure. Damages could cause a homeowner or local town thousands of dollars as sea level rise progresses. With the loss of habitat from climate change, the shellfish industry and other fishery industries will be heavily impacted in the North Shore. There is also a possibility that tourism will decrease as climate change affects the marsh. This could ultimately impact the local economy. Plenty of organizations, including the National Oceanic and Atmospheric Administration, Massachusetts Office of Coastal Zone Management, and land trust organizations such as the Essex County Greenbelt and the Trustees, work hard to conserve, protect, and restore the Great Marsh system. Currently, the Geography and Sustainability Department at Salem State University is using advanced geospatial technologies, such as drones, satellite imagery, and geographic information systems, to map marsh ecosystems and monitor and model changes caused by climate change.
All right, thank you, Danny. That was great, and an example of why I'm so proud of our students. So I hope I left you with, as I said, a little bit more understanding of climate change, some sense of urgency and pride in ways at a school. And I want to thank you for coming out and listening. And if there's any questions, I am open for that. I don't know if there's online questions coming in. Oh, that would help. Yes.
Like to see us reduce the use of fossil fuels are also anti-nuclear power. What do you think?
Yeah, so there's a lot of trade-offs that we have to think about, and so are the detrimental effects of nuclear power worse than a warming world? Yeah, I don't have the answer to that, but it is we've got some hard choices that we have to make. So it must be like 8 years ago or so, my sons went off to summer, it's kind of like wilderness camp, and they hike and canoe and stuff up in Vermont where there is no Lyme disease. And they come back and they've got this rash and an itch and stuff. And it's unlikely that Lyme disease is the problem because they're up in Vermont where Lyme disease does not exist. And after a lot of torturous time, they eventually were diagnosed with Lyme's disease. So as Professor Hayes points out, with our warming world, especially with the warming winters, new life is always trying to expand its range. And so these ticks and mosquitoes and other pests are going to expand they are expanding into our range. Lyme's disease is now up throughout New Hampshire and Vermont and Maine, as are other new diseases. And so in the health field, that's another thing. We actually went out west when they had Lyme's disease, and the Western doctors, health people, had no idea what Lyme disease was. So for those of you that are getting into the health profession, there are going to be some new vectors, new diseases that you're unaware of, and need to become aware of them as they move into our environment. It was nice. Yes, it is. We are. So that's a great point. Is water vapor itself is a greenhouse gas? If you've ever been camping and it's a clear sky, it's generally going to get cold at night. If you're camping and it's cloudy because there's all that moisture up there, it tends to be a warmer night unless some air mass moves in, because the water maintains the heat. And so we have documented that our atmosphere since the mid-70s has had more water vapor in it than long-term averages. And the issue about water vapor is it lives for a short time in the atmosphere, where carbon dioxide can live up there for 1,000 years. Methane can live up there for decades. Water vapor can come and go. So if the climate does start to cool, then the water vapor will come out. Yeah, I was wondering that myself, but Vermont was one of the states warming the fastest, and I didn't bore you. Originally I had every state's graph in there, but someone told me I should cut back on my graphs a little bit, so I didn't show all those graphs. But the data also, right? Each state had like 8 data points. So because we needed data that was verifiable all the way back to 1900. So I'm wondering if with more finer data, we'll see the coastal area warming up more than inland, but the data we couldn't tell. Yeah. Alan. Hi. I believe it's been completed. Maybe Ms. Gallagher can. So we had the geothermal. It had some issues. It is running, but not as optimally as it would be. One reason is we're an early adopter. Someone has to be an early adopter. Someone has to move forward, and so we can expect some things like that, some hitches to happen like that. Oh my gosh. Okay, will do. So the question is there any evidence that we might be moving into a glacial period? So I didn't go into this, but there's a number of things that happen that determine how much energy comes from the sun. And one of them is the Earth's orbit actually over 100,000 year changes from a circular to an elliptical. Also, the Earth is actually wobbling every 44,000 years. It makes one wobble. So it's on a different time scale. So in the past, that changing orbit and that changing wobble created various ice ages. There's been many ice age periods. In fact, when I showed you that carbon dioxide temperature, you probably noticed it went up, it went down, it went up, it went down. That was that change. Right now, there is, and if we didn't put any greenhouse gases in our atmosphere, we would be heading slightly for a cooler time over a long period of time. But we've overwhelmed the system with greenhouse gases that we're not going towards a glacial period by any means. Yes. Yeah. So all fossil fuels at some point in their life input toxicity into our environment. A lot of them at the source, like coal mining and the like. Sometimes in transportation, like the Exxon Valdez. Sometimes in the use of it. And so there are toxic chemicals in gas. And so, right, we put a scent into it so we can tell when it's leaking. I'm sure most people here know the scent of natural gas. And so natural gas leaks, and it's got chemicals in it that have been shown not to be good for our health. It causes asthma in young children. And so now the science has showed us that health-wise, it's probably not a good idea to use gas stoves, fake fireplaces, things like that, because of the long-term toxicity. So the question is about where in New England, we have a lot of coastal areas. And with sea level rise, are we going to have to move inland? Some places, whether we want to or not, we will have to abandon and move inland, I would say. A lot of ecosystems have to abandon where they are and move. In a stable world, things kind of stay in put. But in an unstable world, things move. And so one thing we need to do is the Great Marsh and marshland is very productive for the beginning of the food chain of our marine environment. And with rising sea level, they can't survive underwater. So they're going to migrate. And so now we've got to plan and preserve areas where they can migrate to. And so it's not only humans that are migrating, but ecosystems are migrating also. And it's absolutely crazy that we're still building on coastal areas where sea level rise and storm activity is going to happen. I didn't talk about it, but with more energy in our environment, we've got stronger storms. And so coastal areas are going to get more storm activity. I do know that some places are, like in Revere, you start to see those new apartment buildings. They have the parking garage on the ground floor. That's smart. That's an adaptation that will last a little while as sea level rises. But yes. So the question is, how can we participate in lowering the carbon emissions? So first of all, understanding climate change, understanding the science of climate change, that what's happening, and based on that science, we can come up with solutions. And so some of us will have a lot of opportunity. People who are in political science may move on and work in the State House. And so in whatever capacity you can, make a difference. Some people will not be in any kind of job, but they may vote and just do an educated vote, choice of what to eat, choice of what car to buy, just educated things. And one thing is we can't individually feel guilty, right? It's not your fault that what's happening, it's society's, what's happening broadly in society. And so we'll try to change society how we can. It might just be raising children that are much more aware of what's happening. Some of us will be activists. You can't feel guilty that you're not being an activist, but just do whatever you can in your life when you come across those opportunities. Sure. Thank you for making me live my anxiety. I try. I really do try to appreciate what's happening today. You know the beauty of our world and stuff. But I will tell you, this past summer, for the first time, I felt like, oh my God, I'm living in the world that was predicted 30 years ago. And 30 years ago, it wasn't. It was almost science fiction, unbelievable. And so realizing that we're living in the world, the climate you all grew up in will not happen again. The climate that we're having right now won't happen again. So that is anxiety producing and the uncertainty and stuff. But okay, that's the situation. And what can I do today? And I try not to feel like it's all my fault, it's all my responsibility. And where I can do things, I'll do it. And I've been part of different environmental organizations and stuff, and I decided education was where I can do the best. And so that's how I do it. But still can't get rid of that anxiety. But maybe that motivates me to realize the urgency and do stuff. But I do try to not let it overwhelm me. And I don't think it should. It's society's issue. That answer your question? Yeah. It's a great question. And thanks to Danny also. Thanks, Danny. That was great. And goodbye to my online group. Hope that you had a good class lecture.